Hello interwebs, welcome to Let's Fix Computers. I've got a Logitech StreamCam here, and it's got a busted USB port. So the USB port got knocked on the back of the computer or laptop or whatever and snapped off. So we're going to try and figure out how to deal with this. We could chop this off and we could buy a generic USB port and connect that on somehow. But a lot of the ones that I've seen are only USB 2, and this is going to be a USB 3 camera because it's 1080p 60 FPS. So I'm 99% certain that this is actually a genuine USB 3 connection because other Logitech webcams of this spec are USB 3. So if we put on a cheap connector that only has the USB 2 pins on it, we're going to lose some of the functionality of the camera. And in addition to that, I don't know if I can find one that's actually going to look nice when we're done. So I'm going to try a different strategy instead. I'm going to take this cable off from the inside of the camera, and I'm going to get another USB cable, chop off the end, and solder that onto the inside. So let's start by disassembling the camera. Now, I've already had a quick look at this, just because I wanted to figure out how it came apart before I started recording. And this little ring on the back of it, you've got to pry that guy out, and then that reveals two screws on the back here. So let's just take those out. So that releases the strain relief. And then this is like a little C-clip, so I'm just going to take that off, put that to one side. And now, if we have a look into the back of the camera, I'm going to try and get this on camera. There is another two screws visible down there now. So let's just see if we can see down there. There's one of them. And there's another one there. So I'm going to poke my screwdriver in and take those out. So now those two are out. Now the front of the camera will drop out. And if we just push the strain relief through the back, we can push that whole shooting match through like so. So I'm just going to pull this all the way down the cable, just so that's out of the way. We'll chop this cable off at some point, but we don't need to yet. So now we get to here. Now, initially I saw that connector and I thought maybe we can find one like it, or I can crimp a new one, but when I actually undid it, it's like a weird sort of blade type connector. I don't know the name of this connector, and I don't fancy my like, this is probably a connector that exists. It's probably it can probably be found, but good luck finding a USB cable with this on the end of it that also just happens to be the correct pin out and all the rest of it. So this is the problem of the video that we need to solve, is we need to pin a new cable onto this. So my plan for this is going to be to remove this connector and just hand solder a wire onto it. So let's roll the intro and we'll get into doing that. This might be a bit of a scrappy repair, and I don't know how proud of the result I'm going to be, but the end goal of this is that any jank that we inflict will be hidden inside the camera where it's not visible, instead of being on the end of the cable where it might be more delicate or liable to break again. On that end, sorry. So, I'll see you guys after the cut. So if we're going to be able to do any work on this at all, we need better access. So I'm going to take out some more screws here and just see what else comes off. This is as far as I've got. I got this far and was like, okay, I think we've got a video here, and put it back together again so we could start from the beginning. But I haven't taken any of this off yet. So that gets me to there. Then we've got another circuit board. We've got a couple of layers to this thing. So I think this is going to pop off, which it does. There we go. So that is our control board. And then the next board down, that's going to be the image processing board. That'll have the sensor on it and probably some image processing. So let's put that to one side now. So as I say, this connector looks pretty obscure to me. We could probably find a JST connector or something for this, but I don't have that. So once again, I'm just going to hand solder onto the pins of that. So I'm going to use my hot air to try and flow this guy off. I might just break it off if I'm honest. I'll try the hot air first. I don't think that's going to put up much of a fight, and we might be able to take that off cleanly without permanently wrecking it. So let's see how that goes. So I'm setting my air to 330 degrees C for this maximum airflow. 330 is pretty low. However, that means we should be able to get this off without wrecking the connector. So hopefully everything we do here should be reversible. And it might take a while to heat the joints at 330, but if we're patient, they will go. That's melting. I probably needed to go even colder. I don't think this is unsalvageable, but like I'm kind of going YOLO on this job anyway, so I might just demolish this connector and just get it off the board. Alright, I singed that guy, but, you know, that's probably still workable. That will probably still function if I put it back on and just bent that back a little bit. So you can see how if I'd gone a little bit slower, if I'd gone down to like 300C and gone slowly, or even just pre-tinned those joins with some leaded solder, that probably would have been, we probably could have gotten that off without damaging it. So while it didn't matter this time, if you do actually need to remove a connector like this without damaging it, you can do it. For the longest time, I just did not understand how it was possible. But yeah, everyone runs hot air really high because, you know, ground planes and stuff like that. But if you go low temperature and just wait a long time, you will just slowly get those joints up to melting point. It's just a matter of time. So now we've got some pads here that we can solder some single wires to. So I'm going to get my donor cable and just see what we're doing. So I've got a donor USB cable here that I'm going to try using. This is a USB 3 cable. However, it's got a Type A connector on one end, and I'm not sure if that's going to work out or not. But in the interest of science, I'm going to sacrifice this cable and see if it works out. So let's start just by chopping the end off of it and just seeing what comes out the end. All right, here we go. Oh. There's a lot of wires in there. Just going to pull back the braiding as much as I can. Might have to trim some of that off. So just by pulling it down, holding it, and then pulling it back down the rest of the cable, we can just shuffle that back. Now I'm going to use some strippers just to take off the end. Let's get this out of the way for a moment. Okay, that gets us to the shielding of the cable. So we'll just unravel this. Pull that all around to one side. Now you'll notice on the old cable we had this guy here. This black wire, whoops, I'm off shot. This black wire here, this is a ground wire, and that will be connected to the shield, which is this metal braiding going around the outside of the wire. This isn't strictly necessary, but it can help reduce noise and stuff like that. I'm probably not going to bother saving it. I think we'll work just fine without it. However, theoretically, for maximum signal integrity and to meet the standards of the cable, you would want to connect that to ground at both ends. So then we have another shield. And I'm going to trim that one off. And we've got a bunch of string in here. I've got to separate out the wires now. And the string is in here to stop the wire from stretching. So we want to try and separate all of those strands out. And I'll trim that as well. Well, these cutters are blunt. Right, where has that gotten me to? We've got a couple of just bare wires. I'm not sure if those are just grounds or what. The green and white are probably our USB data plus and data minus. I'm not seeing enough wires here, so I'm a bit worried. Oh no, there's a lot. There's still quite a lot to find in here. Okay, I'm going to carry on unwrapping all of these wires, and then I'll show you what we have at the end of it. Okay, so I've split these wires up, and I've currently just got them fanned out. The first thing I want to check is all of these just bare wires that are unsheathed and unshielded. I want to double check that these are all ground, which I would expect them to be. So I put my multimeter into continuity mode so it beeps. I'm just gonna I'm assuming you guys can hear it. Either way, beep beep. And let's just check. So if I put the red probe on this big shield ground wire, that's ground. That's ground. That's ground. That's ground. And that's ground. So yeah, basically everything that is just bare metal is ground, which is what we would expect, but it just means that there's no surprises there. So we only need one ground, so technically we could probably trim all of those off, but I'm not going to do that quite yet because I want to see what the inside of the old wire looks like and stuff like that. But we've got a couple of pairs. We've got, I think we've got a positive and a negative. The negative is ground. We've got data plus and data minus for USB 2. And then we've got another 2 data pairs, which are our USB 3 data pairs. And these 2 extra pairs are called SSRX and SSTX, positive and negative as appropriate. So this makes sense for USB 3, but now we need to figure out how all of this would join up for a Type-C connector. But how many pins have we got total here? We've got 2, 4, 6 data pins, and then 8 for positive and negative. And the connector that we're trying to go to is a 10-pin connector, I believe. Let's see, we've got 2, 4, 6, 8, 10. Yeah. But also, like, 2 of those are red, so those are probably both positive. So I'm fairly certain. So that so 2 of those are red, and I see 2 black wires in there as well. So that's quite likely 2 negatives. So in all probability, what we actually have there is 2, 4, 6 data pins, and then we've got 2 for positive and 2 for negative. And that would account for everything we've got here. So we seem to be on the right track. So we need to figure out what the pinning for this is, and then we can line it all up. And from a quick Google search for a USB 3 pinout diagrams, this one is showing us a color scheme that matches the wire that we've got. So we've got white and green for our USB 2 D plus and D minus, and then we've got blue and yellow for super speed transmit, and then we've got purple and orange for super speed receive. And that matches what we're looking at here. We've got blue and yellow here, that's SSR, and we've got purple and orange, which is our blue and yellow for SST, and purple and orange for SSR. So now we've identified which of these data sets are which. So this means that we don't have to figure out what the pinout at this end is. We now know what all of these are because this cable is using standard issue colors. So that's good news for me. It saves me a lot of work because I was just sitting here thinking, how the hell am I going to figure out which ones are which? So yeah, color standards, everyone. Now we need to figure out the pinout for the old cable that came off of the webcam. So I've pulled up a Type-C connector pinout here. And you can see that the color scheme on this one is different. So ignore the colors for the time being. So this one I'm going to have to buzz out. with the multimeter. So what I'm going to do is I'm going to use this diagram, and with my multimeter in beep mode again, I'm going to go across these pins and see which ones beep on which ones. So we can build up a diagram. So firstly, let's start up with the red pins and confirm that those are indeed power. So I'm going to see if they're common first, which they are. So the two reds are joined, which would make sense. So we should find that these connect up to I'm going to go with the top row of pins. The bottom is identical, so it doesn't really matter. So let's go for the fourth pin down. So that is 1, 2, 3, 4. Cool. And likewise, it should be 9 going the other direction. So 12, 11, 10, 9. Cool. So far, so good. So that's our power pin. Let's check those negative pins. Are they common? Yes, they are. So these will connect to the outer pins, which they do. Yep, lots of grounds on this thing. So good. All right. So that confirms my theory that we've got 2 positives and 2 negatives. So we've got a white and a green. So moving from the red, going from right to left, the next ones are white, then green. So that is almost certainly going to be our D plus and D minus. So let's confirm that. So white. Okay, this is going to take me a while, so I'm just going to fast forward through this and I'll tell you the results once I've done this. You can see what my process is here. I'm basically just buzzing out the pins. Right, that's that sorted. So here is the pinout that I've just determined from this. Red at the top is pin 1, and that can be confirmed from the orientation on the board. So we've got our red pins for V+, then we've got our USB 2 data minus data plus, then we've got a ground, then we've got our SSTX pins, then another ground, and then our SSRX pins. And you might go, that's weird that they put the grounds in there instead of just putting the grounds down at the end of the cable. But what's going on here is that we've separated our data pairs with ground wires between them to reduce crosstalk. So it looks kind of random, but when you realize that they've just separated out the data pins with ground pins, it makes a lot of sense. So let's go back to the, let's come under the microscope now, and we're going to take a look at the circuit board that we pulled off of the camera. And now we can do a little bit of sanity checking as well. Is if we have a look at the connector here, the bottom of the board isn't flat, so it's hard to hold it steady. Here's pin 1 denoted by the dot, and our first 2 pins are positive. So you can see those are common together and go around here up to this test point, and probably, yeah, there's a veer going through the board there as well. So the first 2 pins being common together confirms that this is the correct way around. Those 2 are reds. Then we've got 2 data pins, and you can see that we've got a pair of data pins because the traces are matched pairs and they are also length matched going up into this control chip. So that makes sense. Then the next one is a ground, and that is connecting onto this ground plane. So again, what we're seeing on the board makes sense with the pinout that we derided. Then we've got another data pair, and another ground pin. So you can see that visually on the circuit board, what we're seeing on the board matches up with what we buzzed out from the wire. So we can check our own work here just by doing a visual inspection of the board. So now all I have to do is solder this to this. So I'm going to get everything viced up. I'm going to preemptively just strip the ends of these wires because that's going to be a pain in the ass. I'm also going to trim back all of the things that we don't need. So I'm going to pick one of these wires that feels like a good ground to me, use that as my ground wire, and trim back everything else that we don't need to tidy up. There we go. I've just tidied up this flare out a little bit more. So I've just trimmed back all the unnecessary ground wires we've got. So we've got 2, 4, 6 data pins, and then we've got a positive and a negative. So we've got more than one negative pin on the board, and we've got more than one positive pin on the board. But because they're common together, it doesn't matter if we don't have a wire for each one of them. They all connect up anyway, and because this is a webcam, it's not going to draw that much power, so we don't really need to worry about current handling and stuff like that. If this was something that needed to be like fully spec compliant to handle anything that USB Type-C is supposed to be able to handle, we'd need to be a lot more worried. However, we can be pretty blasé about this. There's only one thing that I have not yet spoken about that we need to consider, and that is the CC1 and CC2 pins, which is the power delivery communication pins. Now, these might be handled in the plug. I hope they are, because in order for this whole cable and this device to be power delivery compliant, it needs to identify itself as a device requesting 5 volts. If it doesn't request anything at all, or it is just non-compliant, then plugging it into certain Type-C ports or a power delivery adapter, for example, will just result in no power being put out. Because USB power delivery can knock out a lot of power, if a device doesn't identify itself, it will fail safe, which means it just won't power on. So we need to take that into consideration. I'm banking that anything that needs to be done there is already being handled at the Type-C end of this cable. If not, we might have to do a little bit of bodging after the fact. Right, let's start soldering. I'm going to start by cleaning off the old solder and putting down some leaded solder just to get fresh stuff on. And I'm going to put my soldering iron at 380 because I'm going to wick this in a sec. Probably don't need that much heat, but it'll be fine. So let's just flood a whole bunch of solder on here, and then we're going to wick it all off again. This will be significantly easier if the soldering doesn't fight me. So flux, and I'm just going to jump up to 400 degrees while I do wicking. Cool. Now I've got some nice clean pads to solder to. I'm now going to tin those all up with some fresh solder again. Now let's just drop the temperature a bit. High temperature makes the soldering easier, but it's also going to burn up the flux faster. So you don't want to use more temperature if you don't need it. There we go. Now what I'm going to do is just pre-tin all of these wires. So it's going to be difficult to show on shot. But I'm just going to, now forgive the focus, let's try and do one that's in focus. Let's get that white one down there. Oh, I've just frayed that. Pull that together. Touch some solder to it. Damn it. This is the time when you need 3 hands, or you need to actually vise up the wire. There we go. So I've just put some solder on the wire. This stops it from fraying and makes it easier to solder. So I'm just going to quickly rinse and repeat on all of these. So first one's easy. That's our positive pins. All right. So I'm going to bring up my pinout again as a reminder. So we've got red, red, white is D minus. And I'll just trim the ends of these as well, just so we've got as little exposed as possible. I probably should have done left to right here because I'm right-handed. There we go. Next up is green. Next up is ground. Gonna need some tweezers for this. Next up is purple. Not sure if I've got enough solder on the pad for that. Nope. Oh, we're cruising. We're cruising. It's easy. Now the next one is TX1 positive, which is orange. That's not very good. Let's try and correct that. That doesn't have enough solder. This is where it all starts going wrong. I want some more flux on here. I'm going to get... yeah, let's add some more flux. And I'm just going to reflow as we go. That's a more confident orange now. Next we have another ground, which we're going to skip past. And now we need RX1 minus, which is blue. Oh, we just lost someone. Shit. Oh, this is when a cascade happens. Alright, I saved it. It's okay. Let's just correct blue. Orange, please. Purple, please. Oh, that's gone very sideways. All right, I think we're there. Whew. You guys probably have a better view of this than me at the moment. If I wasn't filming this, I would go under the microscope, but I need it in the vise, and well, no, it's on. Kind of just did that. I kind of just freeballed that. Let's clean up a little bit. I'm not being too careful as I clean, because if it can't survive being scrubbed with a Q-tip and alcohol, then it's not on properly. Same with the toothbrush, which I'm going to come in with now as well. If it can't take some mild toothbrushing, then it ain't on properly. Nice. Okay. I need to thread the wire through the body of the camera first. It's time for a musical montage, everyone. Let's go. Good. Now we're done. Probably. Next, I'm going to take this out the vise now, and we need to put it back onto the rest of the camera. So we're going to put this back on here. That went round like that. Nope, that went around like that. There we go. All the connectors are lining up there. And this guy went on the back like that. Okay, so now what I want to do is just try and pull these up and just wrap that up slightly. Being kind of gentle here. That will do it. And I'm just having a quick look. Yeah, none of those pins are going too short together. So I think what I'm going to do now is get the hot glue gun. Oh. Where are you going, camera? What are you doing? Right, now I'm going to get the hot snot gun. And I'm just going to put some hot glue down across those solder joints. This is where it gets ugly, but we want to put some strain relief on these just to give it some durability. I hate glue guns, but man, they solve a problem. So this needs to go in a certain way around. It needs to go in so these two thermal pads contact the two bumps in there. So that needs to flip over. That's going to fit back in there. And now I'll get the other two screws in the back. Why didn't I take this off earlier on? We're still going to have a blob of hot glue on the back. That's kind of just unavoidable, but now I'll stuff all of this braiding in there. Oh, it's a shame I forgot to put the outer ring on there. Okay, I'm going to flood fill this with hot glue now. But before I do that, let's test if it actually works. And the answer to that is yes. The camera seems to be working just fine. So, good result, good result. So these final touches are going to be a little bit ugly, but necessary. Let's get this circlip back on the back. So the original had this white ring that then goes over that. I wonder if I can get this off somehow without completely butchering it. I'm going to just very gently snip that so I can take it off and put it on again. Okay, so that ring fills some of the gap, but we're still going to need to do a little bit of hot glue filling here. So this bit's going to be kind of ugly but necessary. Here goes nothing, everyone. Right, oh, this glue is terrible. It's going all horrible in yellow, and there's glitter in it from when I used glitter in this glue gun 10,000 years ago. Okay, right. Let's just try and put that in flat. Again, we can remove some excess in a minute. Just need to munge it in so the cable is straight. Terrible. Okay, fine. Well, that wasn't everything I hoped and dreamed, if I'm honest, but the cable isn't going to fall out. Okay, that's not exactly stellar. I'm kind of annoyed that the hot glue has just discolored that amount, but it's a pretty crappy glue gun I've got. But we have now got strain relief there, so this cable is safe to be pulled and wrapped and things like that, and it's not going to rip off all of the solder joints inside the camera. So it's not as pretty as a finish as I'd hoped, but part of me is just like, I don't know what I expected. I knew that I was going to have to hot glue this last bit back in, but it is what it is. So that, folks, is how you put a new cable on a Logitech StreamCam. I think it might have been easier just to go with the replacement connector at the other end, but you know, there are many ways of fixing a thing. See you next time, folks. Bye.